to a new video from Machine Learning with Hamza. So as the title indicates, in today's video we're gonna try to build a freestyle rap bot. So to do that, we're gonna fine-tune a language model for text generation. Then we're gonna use it to generate freestyle rap bot. So we're gonna feed it the beginning of a sentence as an input or as a prompt, and hopefully the model will generate rap lyrics using that prompt. So I hope you learned something new in today's video, and if you find it interesting, don't forget to subscribe to stay tuned for more videos to come. So without further ado, let's get right into it. Okay, so here we have the notebook that we're gonna use in this video, and of course, as usual, any material that I'm going to use is available via links in the description. You can download and follow along. Okay, so then let's start. So first of all, we're gonna gather and scrape some data. We're gonna clean it, then use it to train our language model. So for the data scraping and data collection, we're gonna use a very famous Python library, which is Beautiful Soup. We're gonna use it to gather some rappers' song lyrics, and we're gonna clean all the data and save it so we can use it afterwards when training our model. Okay, so in the first section here, we're gonna, as I said, create our data set. So first we're gonna head over. So first let's head over to the website AZ Lyrics, which is the website that we're gonna use to collect songs lyrics. So as you can see here, we have the list of all the rappers in alphabetic order, and we're gonna select a few of them. And okay, so let's, for example, check this one, and we're gonna collect all the songs lyrics from multiple rappers, and of course create our data set and clean it. Let's get back into our notebook. So we're gonna need some basic libraries like time, regular expressions, OS, TQDM, Beautiful Soup, requests, etc., pandas, scikit-learn. Here I created the list of rappers that we're gonna collect the data of. So we have Tupac, 50 Cent, Eazy-E, etc. So let's create the list. We have 15 rappers. Then we have the get AZ URL. Basically, this function takes the name of a rapper and returns the URL for its discography on AZ Lyrics. Okay, so next we have, let's run it. Next we have our parsing website HTML. So once we get the URL for a rapper, we can then use Beautiful Soup to parse the HTML of its discography and return lyrics links, which are all the song lyrics links for each rapper. So first we will create the rapper's lyrics links list, which will contain a list for each rapper, and each list will contain all the song lyrics' URL. And to do that, we simply get the URL. We use the request to get the URL content, and then we create our soup by searching for certain classes and divs. We can extract all the information we need. These are, of course, the basic functions or methods of Beautiful Soup that you can use, and you can find their descriptions on the documentation. So here we're looking for the list album item, which will return the tracks list. And for each track in that tracks list, we're going to extract the hyper reference or the URL for the lyrics. And and we're gonna save it or append it to our rapper's lyrics links list. One final thing that it is very important when scraping from websites on the internet, you need to include this time sleep. So without this sleep, basically the CAPTCHA will detect unusual activities and will block your IP address from accessing the website. So I've tried here multiple values, and I find that at least you need 13 seconds to surpass the detection of the CAPTCHA. So that's it for the cell. We're gonna run it to get all the links. It will take around 3 to 4 minutes. Okay, so let's wait for it. Okay, so finally we extracted all the discography titles for each rapper, and here we converted to dictionary, which is more easy to use. We have the keys are the rappers' names, and the values are the rapper's lyrics links list, which we just collected here. You need to check, of course, the tracks list and the lyrics links. So if you find any empty items in this list, or if you find any empty list for rappers, that means the CAPTCHA detected unusual activities and has prohibited the library here from accessing the URL. So what you need to do is to manually visit the website and confirm that you're not a robot, and try to increase the value here of the sleep time a little bit and try again. But if you try that multiple times, actually it will block your IP address and you won't be able to access the website AZ Lyrics for several hours. So beware of that. But to make sure that you don't get your IP blocked, you need to have some high value here, like 13 or 14. Okay, so here, as you can see, the tracks list for the last rapper. We have the div class that we extracted. So we have here the list items. Actually, for each item we have a link for the song lyrics. Here we have the rapper Dex and the song name. So after that, in the lyrics links, we extracted the lyrics links for each song. And as you can see in this list, we have actually an accessible link or URL. Okay, so that's fine. Let's move on to the next part, which is going to be extracting the actual text or lyrics of each song for each rapper. And this part is fairly simple, but it will take a huge amount of time. It will take, as you can see here, around, so for each rapper, it will take around 1 hour or 1 hour and a half. And we have 15 rappers, so it will take about 20 hours to finish all the data collection, to finish all the data collection or data scraping. But let's not focus on that for now. So we start first by creating this dictionary, which will be then converted to a pandas data frame. So we have in the first key the rapper, which we already have as an information. We're gonna extract the title, which we have here, but we're gonna extract it from the lyrics. So let's, for example, try to access one song lyrics. Let's copy this and paste it here. Okay, so we have the song name here, hit 'em up, and then we have the lyrics. And this is basically the usual structure of song lyrics on AZ Lyrics. So we're gonna loop loop through the wrappers, and for each wrapper we loop through the URLs that we have extracted. And for each URL we're going to create as usual the HTML soup, and we're going to extract the lyrics from it. These are some steps for cleaning. So here, for example, we remove any tags written between brackets, and also we remove here some empty lines, so we take only the text. And after running this, we convert the dictionary to a data frame, and we obtain this data frame, which contains the wrapper, title, and the lyrics. Okay, so you need, if it is the first time running this notebook, you need to save the data frame so that you can use it afterwards. So I already have saved the data frame, and I only need to read it here. Okay, so here it is. Next we're gonna have some cleaning steps. So first of all, I noticed that there are many Unicode in lyricses, so we need to convert them to ASCII so that the model can process them and can tokenize them. So this is a simple function that you can use to convert any Unicode from this type into ASCII. And of course you can add other methods that you can use to clean strings. So here the input is a string, so you need to keep that in mind. Afterwards we're gonna use this function that we just defined to clean the lyrics, and here's the result. After that we have this function which will be used to remove duplicated lines, like lines from courses. So for example here we have a song lyrics by Soulja Boy, and we have these lines are repeated 3 times or 4 times. So we're going to remove all the repetition and keep only one copy of the repetition. That's what we achieve in this part of the function. And also we need to remove any sentences between parentheses, which usually indicates ad-libs or things that's been said that are not part of the freestyle or rap lyrics. So we need to clean that, and it is achieved here. So this is basically the function remove dubs and ad-libs, and as you can see we can apply it for this lyrics, and the result is, as you can see here, we only have one occurrence of the lines in the course here, and all of these are empty lines which will be then removed when stacking all the lines together, or all the list items together. And to apply that to all the song's lyrics, we can loop through each item in the dataset and apply our function, and then stack the lines in this produced list together to get rid of these empty items. And this is the result. So you can compare the first or the original lyrics, and then we have the cleaned lyrics. So from each course we have only one occurrence of duplicated lines, and then we have the actual verse, and it goes on like that. Afterwards, so we finished cleaning, we need to create our train and test set, and that's what we do here using the test or train test split. Okay, so we need to save it, and that concludes the data scraping and cleaning steps. So now let's move on to the creation and fine-tuning of the language language model to create our freestyle rap bot. We need some other libraries that we're going to use. We need transformers and we need dataset. And we also need to install Torch, the GPU version, because we're gonna train or fine-tune a deep learning model from transformers. And if you have a GPU, it will take less time to train on it. So make sure to have Torch in the environment or PyTorch. Okay, so the first step is the pre-processing to get the data ready to feed into the model. So to do that, we have some steps that we're gonna follow. First of all, we're gonna create the dataset. We're gonna load the CSV files and using load dataset, we're gonna create the datasets for training and validation, which is the function here from datasets. Then we have here this function which shows some examples or some random examples from the dataset. You can check the lyrics here to make sure everything is cleaned and is as you want it to be. Moving on to the next part, we will use the Distill GPT-2, which is a fairly small language model, and it is of course used for text generation, and I've chosen this one so I am able to train it on my GPU, which is only a GPU with 6 gigabytes of VRAM. So make sure if you choose a language model that you have the hardware to train it, or use Colab or some other platforms like Kaggle to train or to run the notebook. So first of all, we need to define our checkpoint or model checkpoint. We need to get the tokenizer for that model, and that's what we've done here. Okay, so let's run it. Then we have the tokenize function, which will be used basically to tokenize the text in our dataset. We're going to use it in the map function here, which will go through each lyrics and return the tokenized version of the text. So after running this one, okay, so the tokenized function is not defined. We need to run this cell first, and then this one. It will take only a few seconds. Okay. So next we can check the tokenization that was successful. We can see here, for example, for the first song, we have the input IDs or the token IDs generated. Okay, so the next step of the pre-processing is to concatenate all the lyrics as we have. Then we split them by chunks of defined number of tokens so that we have uniform length of sequences to input to the language model. First, we define the block size or the sequence size. It will be of 256 token. So each input sequence to the language model or to the GPT will be of length 256. So I've tried multiple values here and I find that 256 is actually fine for my hardware settings. Okay, so to achieve that and to split our whole dataset into sequences of size 256, we have this function, which is the group text. So this function will concatenate all the text, will drop the remainder, and then split by chunks. And of course, the final result will be stored under labels. So using this function and the map method, we're gonna map all the tokenized dataset to convert it or to get it to the uniform size of 256 block size. Moving on, so we can run it, of course. Okay, so this part will verify if the group text function worked perfectly. So here we can take an example, for example, the first song lyrics or the first generated sequence, and we check if its length is equal to the block size, and if it's not, it will generate an error here, error message. The tokenized input sequence has different length than the defined block size. Next, we need to define our trainer. So for that, we can use this auto model from transformers, and using the from pre-trained of our model checkpoint, we can define our model. Then of course we need to define the training arguments. So we need to define first of all the model name. We need to define the evaluation strategy, which is usually epoch, and the learning rate, the number of training epochs, the weight decay, the warm-up steps. You can, for this application, leave it as defaults or maybe lower the learning rate a little bit. And basically that's it. You can check the training arguments parameters in the documentation if you want to tune the training process a little bit more. But I find that leaving the default values is fine. So then we define our training using our defined model, which we defined here, and using the training arguments. And of course we give it the training and validation sets. So here you can import Torch just to check for its version and whether it is using the GPU or CPU. Of course the version using CPU will include here plus CPU. After that we just need to run the .train method on the trainer. So the training process took around 1 hour to train on my machine, and that's not a very long time. You can you can change then parameters and try to find the best set of parameters to get the best result. Okay, after the training, we can check for perplexity, which is a metric used to evaluate text generation models. And as a rule of thumb, the less perplexity the model has, the more it is able to generalize. And 26 is not a very bad value, so I'm happy with that for now. So finally we can move on to the fun part, which is the generation, and we can test our freestyle rap bot. So here we're gonna use the model.generate. We're gonna give it the beginning of a sentence, or let's say a prompt, maybe the first sentence of a freestyle, and let's see what it can generate. I forgot to mention that the dataset that we trained the model on, or we fine-tuned it on, includes a lot of bad words or profanity. So if you want to remove that, you can use this bad word ID or bad word IDs in the parameters of the generate method. But first you need to get the bad words tokens or list of tokens using this function. So you tokenize, you input here the list of bad words, and it will generate the tokens for those bad words, which you will need to feed for the bad words IDs parameter here, and it will generate text without using the set of words that you indicate. And here we're not gonna use that. So here I've chosen the I'm Not Afraid start, which is taken from the song by Eminem. So after generating, Here's the generated lyrics. I'm not afraid. You can ride on it and ride on it. You just want to know how you feel. I'm not afraid. Just tell me. Don't believe me. You can feel that it has some potential. It has also the tendency to repeat the phrases. Like you can see here, I'm not afraid. It was repeated. You can ride on it and ride on it. It is repeated. So I'm happy with that. It is obviously trained on a few song lyrics, and if you can train it on much more data, you can have better result. Of course, also if you use a bigger or larger language model for text generation. Okay, so after that we need to save, and of course we need to save it so that we can use it through the pipeline API, which will be faster to generate text and more easy to and easier to use when playing or having fun with the RapBot. So first of all, we need to create our pipeline here. Once it is created, okay, we will now generate an output again for I'm not afraid, and let's then display it. Okay, so here generated I'm not afraid, I'm an addict, etc, etc. And when I get a new pair of sneakers, it's real hot. And as you can see, it uses some of the ad-libs, mimicking some of the songs. Obviously we tried to clean them. Maybe the cleaning process left some ad-libs, and that's why it learned to use them. Let's try another phrase or prompt. Let's say lose yourself and see what it would generate. Okay, it said lose yourself with all those tricks that you had when I first met you. I've been through it, never could have told, no obstacles. And as you can see here, it really tries to generate some short lines, but it lacks a little bit of rhyme or a little bit of rap imprint. And as you can see here, it also repeats some lines. Maybe it won't mimic the course structure, but it is actually failing a little bit. For the most part, it doesn't have or doesn't make much sense. So we need to work on that to have better performance on this part of the songs. Let's, for example, try and generate my name is Hamza. Okay, let's see. My name is Hamza. When you're down and there won't be no reply. I'm a man for life and you owe me money. I ain't no homie that I am. If I can't get the job, then I'ma have a wife and a brother. I'm a black man with a dream in sight. Okay, so it is fairly acceptable. It still has a lot of room for improvement. Okay, one last thing that I want to show you is when you generate lyrics, if you really don't understand how the rhyme structure works, you can head over to this website, RapPad. You can pass the lyrics here, save it, and once you save it, you can back to editor, get back to editor, go to your dashboard, and here you can check the blueprint of the song or of the generated lyrics, and it will give you a lyrical grade based on the rhyme length, etc. And here it will generate the rhyme structure. So I find this is very useful to check the performance of the model, and it is a very fun way to test the model. So okay, this is it for the rap pad. Okay, so finally, as I said, we can do much more to improve its performance. So the freestyle rap bot, for now, it works, and it generated lyrics with fairly acceptable performance. However, it can do much better if we spend more time on it, working on it and improving it. And that's it for this video, guys. I really hope that you find it fun and easy to follow and interesting. So until next video, keep learning and have fun with machine learning.